On today's episode, we're going to be looking at separation techniques part 2, specifically more on density, boiling point, and electrostatic attraction. Hey guys, my name is Gary and welcome to Synergy's new syllabus web series. We know that many of you guys out there will struggle with the new syllabus, so we decided to create this web series to help you smash your HSC. So let's get started. Again, I won't give you the full rundown of each separation technique, but only the important stuff just for your exams. So just as a reminder, when you're answering separation technique questions, you need to do two things. Firstly, you want to state the physical property involved, and number two is to briefly explain how the separation technique works using the appropriate equipment, as well as always draw a diagram as always super useful for chemistry and any science course out there. Again, with this video, I'll start with the physical properties first, and then the appropriate equipment and method. Density. Density always looks at undissolved solids and liquids or immiscible liquids. In Year 11, there are 4 separation techniques associated with density. So you got sedimentation and decanting, filtration, centrifugation, and using a separating funnel. So starting with sedimentation and decanting is pretty simple. A good example is when you're washing rice before you cook it. Sedimentation is letting the more dense particles settle at the bottom, in this case obviously your rice, and decanting is simply just pouring off the liquid to allow the solid to remain. With filtration, many of you should have done it in Year 7 to 10, and this is how the usual apparatus looks like. Usually you have a mixture like sand, water, or even salt. Obviously, as the sand does not dissolve in water, but the salt does, so what happens is as you pour the mixture down the filter funnel, the sand will become residue on the filter paper and the salt water will appear as filtrate in the beaker at the bottom. You can then separate the salt from the water using distillation or evaporation depending on if you want to keep the water or not. So now looking at centrifugation, this is pretty simple. Most of the time this is used to separate blood into its component parts, as you might know. So just to ask you again, is blood a homogeneous or heterogeneous mixture? Well, a lot of students get confused with this, but remember, it's always a heterogeneous mixture. If you talk about centrifugation in your exams, not only do you have to mention that it uses a centrifugal force, but also how it uses sedimentation to allow the most dense substance to settle first. Lastly, looking at the separating funnel. So remember, it's used to separate what we call immiscible liquids. So immiscible liquids are liquids that don't mix with each other. For example, look at oil and water. So remember, in the separating funnel, the high density liquid will always settle first. So with the case of oil and water, water will actually always settle first because it's a lot more dense than oil. Boiling points. When you look at boiling points, we're pretty much always looking at distillation, which is then broken down into 2 particular categories. So firstly, you have simple distillation, and secondly, you have fractional distillation. So why do we use distillation? Well, remember how for the separating funnel, we looked at immiscible liquids, liquids that don't mix. Well, for distillation, we're looking at miscible liquids. So these are liquids that mix really well together. Take for example, ethanol and water. So the difference between simple distillation and fractional distillation is simple distillation is for liquids that have vastly different boiling points, whereas fractional distillation are for liquids with very similar boiling points. Take for example, again, ethanol and water. They have very similar boiling points. Because of these differences, fractional distillation will require what we call a fractionating column. So what's the purpose of a fractionating column? Well, when we look at what it is made of, you can see that there are these beads inside the column. And these beads provide a surface for rising vapors to cool on, and it condenses them, allowing these liquids to fall back down again. Thanks for watching today's video. I hope that our web series will bring you immense amounts of value for your studies and the HSC. For more information, visit our website, synergyhsc.com. Stay tuned for the next episode.